Hello everyone. In this lecture, we shall study the general and particular solutions of a differential equation. In the previous lectures, we have seen the definition of a differential equation, the order and degree of a differential equation. Uh, Coming to the general and particular solutions of a differential equation. Before beginning the solution of a differential equation, I suggest you to go to the first video of this chapter and just watch the definition of differential equations so that you will exactly understand what is the solution of a differential equation. So in the first lecture we had seen that a function y equal to f of x, a function y equal to f of x when differentiated with respect to x gives a differential equation. So we had called a differential equation as any equation that involves derivatives. So what will be the differential equation of this function? It will be dy by dx is equal to f dash of x. Dy by dx is equal to f dash of x. So therefore it is very much clear by looking at this particular example that when we differentiate a function y equal to f of x, okay, with respect to x, we will get its differential equation. However, what will you have to do when you have to, from the differential equation, if you have to get back the function? Of course, you will have to integrate. Why? Because in the previous chapter we have seen that differentiation and integration are the inverse processes of each other. So if you differentiate y equal to f of x, you are getting the differential equation. So differential equation na ನೀವು integrate ಮಾಡಿದ್ರೆ ನಿಮಗೆ ಆ function ಬರುತ್ತೆ. Fine. So how can we define the solution of a differential equation then? So ಈಗ ನಾನು I will take a differential equation. Let's say I will take an example. Okay, I will take an example. Let us say dy by dx is equal to 0. dy by dx is equal to 0. So what is the solution of this differential equation? Okay, to understand that, what I will do is I will write this down as d by dx of y equal to 0. Of course, it is the derivative of y with respect to x. So I will write down the differential operator, that is d by dx outside, so that I will have y here. Okay, so it is that function y equal to f of x, okay, when differentiated with respect to x gives 0. Okay, that is called as the solution of this differential equation. So what is the solution? It is that function y equal to f of x when differentiated gives 0. So for that matter, if I take any differential equation, it is that function y equal to f of x which satisfies the differential equation is called as the solution of a differential equation. But what do you mean by the general solution and particular solution? I will come to it now. Okay, I will consider one more example. In this case, what will be the solution? We have d by dx of y is equal to 0. So what when differentiated gives 0? A constant. So therefore y is equal to a constant k, where k is any real number, is called as the solution of this differential equation. So this is the solution. I will tell you whether this is a general solution or the particular solution a bit later. Okay, if I consider one more differential equation, let us say dy by dx equal to, I will take a simple function, let's say 1. Okay, now this implies, can I write this down as d by dx of y is equal to 1? Yes, of course, yes. But now what when differentiated will give you 1 anta helidre, you will immediately say y equal to x. Yes, is this a solution? Yes, this is a solution. Yes, this is a solution. But this is not the solution. This is not the solution. This is a solution. ಇದು one solution ಮಾತ್ರ. ಹಾಗಿದ್ರೆ ನೀವು ಕೇಳಬಹುದು ಬೇರೆ ಬೇರೆ ಸೊಲ್ಯೂಷನ್ಸ್ ಇರುತ್ತಾ ಸರ್? ಎಸ್ ಇರುತ್ತೆ. ವೈ? ಇಫ್ ಐ ರೈಟ್ y equal to x plus 1, ಡಿಫರೆನ್ಶಿಯೇಟ್ ಮಾಡಿ ಏನು ಬರುತ್ತೆ? You will definitely get d. ಇದನ್ನ ನೀವು ಡಿಫರೆನ್ಶಿಯೇಟ್ ಮಾಡಿದ್ರೆ you will get dy by dx is equal to 1. Definitely. So therefore ಈ ಡಿಫರೆನ್ಶಿಯಲ್ ಇಕ್ವೇಶನ್ ಎರಡೂ ಸೇಮ್. ಸೊ therefore y equal to x plus 1 is also a solution. ಹಾಗೆ ನಾನು y ಯಾವುದೇ ಕಾನ್ಸ್ಟೆಂಟ್ ನ ಆಡ್ ಮಾಡಬಹುದು. y equal to x minus k is a solution. y equal to x plus pi is a solution. So for that matter, any function of the form y equal to x plus k is a solution of this differential equation. So this y equal to x plus k is basically denoting different solutions for different values of k. Let's say y equal to x plus 1, y equal to x minus 2, y equal to x plus root 3, or y equal to, let's say, x minus e, something like this. So basically ಇದು ಈ ಎಲ್ಲ ಸೊಲ್ಯೂಷನ್ಸ್ ಅನ್ನು ಕೂಡ ರೆಪ್ರೆಸೆಂಟ್ ಮಾಡ್ತಾ ಇದೆ. ಯಾವುದು? y is equal to x plus k. ಇದೆಲ್ಲ ಸೊಲ್ಯೂಷನ್ ನ ರಿಪ್ರೆಸೆಂಟ್ ಮಾಡ್ತಾ ಇರೋ ರೀಸನ್ ಏನು? ಇಟ್ ಈಸ್ ದಿಸ್ ಪರ್ಟಿಕ್ಯುಲರ್ ಕಾನ್ಸ್ಟೆಂಟ್ k. ಓಕೆ, ಈ ಕಾನ್ಸ್ಟೆಂಟ್ ಗೆ ನಾನು ಯಾವ ವ್ಯಾಲ್ಯೂ ಬೇಕೋ ಆ ವ್ಯಾಲ್ಯೂ ಹಾಕೋಬಹುದು. ದಟ್ ಈಸ್ ಒನ್ ಥಿಂಗ್ ದಟ್ ವಿ ಹ್ಯಾವ್ ಟು ರಿಮೆಂಬರ್. ಅಂದ್ರೆ k does not have a fixed value here. So such a constant is called as an arbitrary constant. It is called as an arbitrary constant, or it is also called as a parameter. Okay, so ಈಗ ಈ ಸೊಲ್ಯೂಷನ್ ಏನಿದೆಯಲ್ಲ, ಈ ಸೊಲ್ಯೂಷನ್ ಎಲ್ಲಾ ಪಾಸಿಬಲ್ ಸೊಲ್ಯೂಷನ್ ಅನ್ನು ರೆಪ್ರೆಸೆಂಟ್ ಮಾಡ್ತಾ ಇರೋದ್ರಿಂದ this particular solution is called as the general solution. ಇದಕ್ಕೆ ನಾವೇನಂತ ಕರಿತೀವಿ? We call it as the general solution. Okay, so what is the general solution? General solution represents all the possible functions which will satisfy the given differential equation. And which is the characteristic feature of a general solution? General solution will have an arbitrary constant. General solution will have an arbitrary constant. So therefore, what is the general solution? What is the definition of a general solution? If I have to define the general solution, what is the general solution? It is the function y equal to f of x satisfying the given differential equation which has arbitrary constants. Arbitrary andre random, andre yavadadru, I mean, that cost, we know that it is a constant, it is not a variable, but we can give any value to it. Okay, so that is one thing that we have. ಅದಾದ್ಮೇಲೆ ಈಗ ಇದೇನು ನನ್ನ ಸೈಡಿಗೆ ಸೊಲ್ಯೂಷನ್ಸ್ ಬರ್ದಿದ್ದೀನಿ ನೋಡಿ. y equal to x plus 1, this is also a solution. y equal to x minus 2, this is also a solution. y equal to x plus root 3, this is also a solution. y equal to x minus c, this is also. ಬಟ್ ಇದರಲ್ಲಿ ಯಾವುದು ಆರ್ಬಿಟ್ರರಿ ಕಾನ್ಸ್ಟೆಂಟ್ ಇಲ್ಲ. ಇದರಲ್ಲಿ k ಗೆ ಪರ್ಟಿಕ್ಯುಲರ್ ಆಗಿ ಒಂದೊಂದು ಕಾನ್ಸ್ಟೆಂಟ್ ವ್ಯಾಲ್ಯೂ ಕೊಡ್ತಾ ಹೋಗಿದ್ದೀವಿ, ರೈಟ್? ಸೊ ದೇರ್ಫೋರ್ ದಿಸ್ ಈಸ್ ಅ ಸೊಲ್ಯೂಷನ್ which does not have arbitrary constants but fixed constants or particular constants. So such a function is called as a particular solution. So what is a particular solution of a differential equation? A particular solution of a differential equation is that function y equal to f of x which satisfies the given differential equation but does not involve any arbitrary constants. So therefore, can we write it down this way? Particular solution. So what is a particular solution? It is that the same sentence will follow. It is that function y equal to f of x satisfying the given differential equation which has no arbitrary constants. ಈ ಆರ್ಬಿಟ್ರರಿ ಕಾನ್ಸ್ಟೆಂಟ್ ಜನರಲ್ ಸೊಲ್ಯೂಷನ್ ಅಲ್ಲಿ ಬಂದಿದ್ದು ಹೇಗೆ ಬಂತು? ಈಗ ಫಾರ್ ಎಕ್ಸಾಂಪಲ್, I will take the same differential equation that I had taken before, that is dy by dx equal to 1. ಈ ಡಿಫರೆನ್ಷಿಯಲ್ ಇಕ್ವೇಶನ್ ಹೇಗೆ ಬಂತು ಅಂತ ಹೇಳಿದ್ರೆ, ಯಾವುದೋ ಒಂದು ಫಂಕ್ಷನ್ y equal to f of x ಇತ್ತು. ಓಕೆ, ಅದನ್ನ ನಾನು ಡಿಫರೆನ್ಶಿಯೇಟ್ ಮಾಡಿದೆ, ನನಗೆ ಈ ಡಿಫರೆನ್ಷಿಯಲ್ ಇಕ್ವೇಶನ್ ಬಂತು. ಸೊ ಡೆಫಿನೆಟ್ಲಿ ಇದನ್ನ ನಾನು ಇಂಟಿಗ್ರೇಟ್ ಮಾಡಿದ್ರೆ ನನಗೆ ಆ ಫಂಕ್ಷನ್ ಆರ್ ದ ಸೊಲ್ಯೂಷನ್ ಬರುತ್ತೆ. ಇವಾಗಲೇ ನೋಡಿದೀವಿ, ವಾಟ್ ಈಸ್ ದ ಸೊಲ್ಯೂಷನ್? ಇಟ್ ಈಸ್ ದ ಫಂಕ್ಷನ್ y equal to f of x that satisfies this. ಸೊ ನನಗೆ ಆ ಫಂಕ್ಷನ್ ಬೇಕು ಅಂತ ಹೇಳಿದ್ರೆ ಐ ವಿಲ್ ಹ್ಯಾವ್ ಟು ಇಂಟಿಗ್ರೇಟ್ ಇಟ್. ಬಟ್ ಇಂಟಿಗ್ರೇಷನ್ ಮಾಡಿದಾಗ ನಾವು ಹಿಂದಿನ ಇಂಟಿಗ್ರೇಷನ್ ಅಲ್ಲಿ ಕಲ್ತಿದ್ದೀವಿ ಏನು? ಎವ್ರಿ ಟೈಮ್ ನೀವು ಇಂಟಿಗ್ರೇಟ್ ಮಾಡಿದಾಗ ಒಂದೊಂದು ಕಾನ್ಸ್ಟೆಂಟ್ ಆಫ್ ಇಂಟಿಗ್ರೇಷನ್ ನಾವು ಬರೀಲೇಬೇಕು. ಸೊ ದೇರ್ ಫೋರ್ ಇದನ್ನ ನಾನು ಒಂದ್ಸರ್ತಿ ಇಂಟಿಗ್ರೇಟ್ ಮಾಡಿದ್ರೆ, ಸಪೋಸ್ ಇಫ್ ಐ ಇಂಟಿಗ್ರೇಟ್ ಇಟ್ ವಿತ್ ರೆಸ್ಪೆಕ್ಟ್ ಟು ಎಕ್ಸ್, ಏನ್ ಬರುತ್ತೆ? ಡಿ ವೈ ಬೈ ಡಿ, ಸಿ ವೈ ನ ಡಿಫ್ರೆನ್ಶಿಯೇಟ್ ಮಾಡಿದ್ರೆ ಡಿ ವೈ ಬೈ ಡಿ ಎಕ್ಸ್. ಸೊ ಡಿ ವೈ ಬೈ ಡಿ ಎಕ್ಸ್ ನ ಇಂಟಿಗ್ರೇಟ್ ಮಾಡಿದ್ರೆ ವೈ ಬರಲೇಬೇಕು, ರೈಟ್? ಈಕ್ವಲ್ ಟು ಒನ್ ಇಂಟಿಗ್ರಲ್ ವಿತ್ ರೆಸ್ಪೆಕ್ಟ್ ಟು ಎಕ್ಸ್ ಏನು? ಎಕ್ಸ್ ಪ್ಲಸ್ ಐ ಹ್ಯಾವ್ ಟು ರೈಟ್ ಸಿ, right? So when I write a constant c, this makes it an arbitrary constant. Okay, so now if I consider y is equal to f of x, let's say either differential equation ತಗೊಳಕ್ಕೆ ಅವರು ಒಂದೇ ಸರ್ತಿ ಡಿಫರೆನ್ಶಿಯೇಟ್ ಮಾಡಿಲ್ಲ. Let us say they have differentiated it twice. Okay, let's say once they differentiate, they will get dy by dx equal to f dash. Okay, so and they will differentiate it once again, and they have got the differential equation. Let's say d square y by dx square is equal to something. That is what they have got. Now the problem is, look, we ಇಲ್ಲಿ ನಮಗೆ ಒಂದೇ ಸರ್ತಿ ಡಿಫರೆನ್ಶಿಯೇಟ್ ಮಾಡಿದ್ರು, ಒಂದ್ ಸರ್ತಿ ಇಂಟಿಗ್ರೇಟ್ ಮಾಡಿ ನಾವು ಇದು ಸೊಲ್ಯೂಷನ್ ತಗೊಳ್ಳಿ ಅಂತ ಕೊಟ್ವಿ. ಬಟ್ ಇಲ್ಲಿ they have differentiated it twice. So to get the solution, if I integrate this differential equation once, I will not get anything. Okay, so let us say ನಾನು ಇದನ್ನ ಸಿಂಪಲ್ ಆಗಿ ತಗೊಳ್ಳೋದಾದ್ರೆ, I will just take the function to be, let's say x. I will take an example itself. Okay, fine. X 1 then 0. Fine. Okay, when I integrate this, I will not get y equal to f of x. I will get the derivative dy by dx, right? So therefore when I integrate it once, d square y by dx square na integrate ಮಾಡಿದಾಗ ನನಗೆ dy by dx ಬಂತು. 0 ನ ಇಂಟಿಗ್ರೇಟ್ ಮಾಡಿದಾಗ 1 ಬರಲಿಲ್ಲ, ಬಟ್ ಒಂದು ಯಾವುದೋ ಕಾನ್ಸ್ಟೆಂಟ್ ಬಂತು. Why? Because we know the integration of 0 with respect to any variable for that matter is a constant, right? Now ಒಂದ್ ಸರ್ತಿ ಇಂಟಿಗ್ರೇಟ್ ಮಾಡಿದ್ರೆ ಒಂದು ಕಾನ್ಸ್ಟೆಂಟ್ ಬಂತು, ಬಟ್ ನಂಗೆ ಇನ್ನ ಫಂಕ್ಷನ್ ಬಂದಿಲ್ಲ, ನಂಗೆ ಡೆರಿವೇಟಿವ್ ಇದೆ. ಸೊ ಅದು ಬರಕ್ಕೆ ಅಂದ್ರೆ ಐ ಹ್ಯಾವ್ ಗಾಟ್ dy by dx, ಅದನ್ನ ತಗೊಂಡ್ಬರಕ್ಕೆ ನಾನು ಏನ್ ಮಾಡ್ತೀನಿ? ಐ ವಿಲ್ ಇಂಟಿಗ್ರೇಟ್ ಇಟ್ ಒನ್ಸ್ ಅಗೇನ್. ಸೊ ವೆನ್ ಐ ಇಂಟಿಗ್ರೇಟ್ ಇಟ್ ಒನ್ಸ್ ಅಗೇನ್, ವಾಟ್ ವಿಲ್ ಐ ಗೆಟ್? dy by dx ನ ಇಂಟಿಗ್ರೇಟ್ ಮಾಡಿದ್ರೆ y, constant integration with respect to x is constant times x plus another constant k, or you can also write this as, if I call this constant as c1, for the second time you are getting the constant c2. So every time you integrate, you are getting one integration constant. ಸೊ ಎಷ್ಟು ಸರ್ತಿ ಇಂಟಿಗ್ರೇಟ್ ಮಾಡಬೇಕು ಸೊಲ್ಯೂಷನ್ ಬರೋಕ್ಕೆ ಅಂತ ಹೇಗೆ ಡಿಸೈಡ್ ಮಾಡೋದು? ಆರ್ಡರ್ ಆಫ್ ದ ಡಿಫರೆನ್ಷಿಯಲ್ ಇಕ್ವೇಶನ್ ನೋಡ್ಕೊಂಡ್ರೆ ಅದು ನಮ್ಗೆ ಹೇಳುತ್ತೆ ಎಷ್ಟು ಸರ್ತಿ ಡಿಫರೆನ್ಶಿಯೇಟ್ ಮಾಡಿದ್ದಾರೆ, ಅಷ್ಟು ಸರ್ತಿ ನಾವು ಇಂಟಿಗ್ರೇಟ್ ಮಾಡಿದ್ರೆ ನಮಗೆ ಸೊಲ್ಯೂಷನ್ ಬರುತ್ತೆ. ಸೊ ದೇರ್ ಫೋರ್ ಆರ್ಡರ್ ಎಷ್ಟಿದೆ ಅಷ್ಟು ಸರ್ತಿ ಇಂಟಿಗ್ರೇಟ್ ಮಾಡ್ತೀವಿ, ಅಷ್ಟು ಆರ್ಬಿಟ್ರರಿ ಕಾನ್ಸ್ಟೆಂಟ್ ಜನರಲ್ ಸೊಲ್ಯೂಷನ್ ಅಲ್ಲಿ ಬರುತ್ತೆ. ಸೊ ದೇರ್ ಫೋರ್ ಇಟ್ ಈಸ್ ವೆರಿ ಮಚ್ ಆಬ್ವಿಯಸ್ the number of arbitrary constants in the general solution is equal to the order of the differential equation, whereas the number of arbitrary constants in the particular solution is always equal to 0. ಯಾವುದು ಆರ್ಬಿಟ್ರರಿ ಕಾನ್ಸ್ಟೆಂಟ್ಸ್ ಇರೋದೇ ಇಲ್ಲ, ಪರ್ಟಿಕ್ಯುಲರ್ ಸೊಲ್ಯೂಷನ್ ಅಲ್ಲಿ ಇರೋದೆಲ್ಲ ಫಿಕ್ಸ್ಡ್ ಕಾನ್ಸ್ಟೆಂಟ್ಸ್ ಇರುತ್ತೆ. ಫೈನ್. ನಾವು ಎಕ್ಸಾಮ್ ಅಲ್ಲಿ ಇದ್ರ ಮೇಲೆ ಕ್ವಶನ್ ಹೇಗೆ ಬರುತ್ತೆ ದಟ್ ಅದನ್ನ ನೋಡೋದಾದ್ರೆ, ಐ ವಿಲ್ ಜಸ್ಟ್ ಮೂವ್ ಟು ದ NCERT textbook now. Okay, so coming to the NCERT textbook, we have the general and particular solution, okay, other definition, whatever I have discussed so far, all those things are given. So if I take up an example, illide example number 3, okay, they have given ಏನು ಅಂತ ಹೇಳಿದ್ರೆ, verify that the function, what function, y equal to a cos x plus b sin x has the solution, I mean is the solution of the differential equation d square y by dx square plus y equal to 0. That is what they have given. So I will take up this question. What is the question? They are asking us to verify that y equal to a cos x plus b sin x is the solution of the differential equation d square y by dx square plus y equal to 0 if I am right. Yes. So how will you do it? ಹೇಗೆ ಮಾಡ್ಬೋದು? ಇದ್ರ ಸೊಲ್ಯೂಷನ್ ಇದು ಅಂತ ಹೇಳಿದ್ರೆ ಎಷ್ಟು ಸರ್ತಿ ಡಿಫ್ರೆನ್ಶಿಯೇಟ್ ಮಾಡಿದ್ದಾರೆ ಅದನ್ನ ನೀವು ಡಿಫರೆನ್ಷಿಯಲ್ ಇಕ್ವೇಶನ್ ನೋಡಿದ್ರೆ ಗೊತ್ತಾಗುತ್ತೆ. ಎಷ್ಟು ಸರ್ತಿ? 2 ಸರ್ತಿ, ಬಿಕಾಸ್ ದೇ ಹ್ಯಾವ್ ಗಾಟ್ ಡಿ ಸ್ಕ್ವೇರ್ ವೈ ಬೈ ಡಿ ಎಕ್ಸ್ ಸ್ಕ್ವೇರ್. ಸೊ ವಾಟ್ ಕ್ಯಾನ್ ಐ ಡೂ? ಐ ವಿಲ್ ಡಿಫರೆನ್ಶಿಯೇಟ್ ಇಟ್ ಟ್ವೈಸ್. ನೀವು ಏನೂ ತಲೆ ಕೆಡಿಸ್ಕೋಬೇಡಿ, ಮ್ಯಾಚ್ ಮಾಡಕ್ ಹೋಗಬೇಡಿ. ಓಕೆ, ಅಂಟಿಲ್ ದ ಲಾಸ್ಟ್ ಸ್ಟೆಪ್ ಯು ಜಸ್ಟ್ ಡಿಫರೆನ್ಶಿಯೇಟ್. ಅದು ಎಷ್ಟು ಸರ್ತಿ ಕಾಣಿಸುತ್ತೋ ಅಷ್ಟು ಸರ್ತಿ ಡಿಫರೆನ್ಶಿಯೇಟ್ ಮಾಡಿ, ಮುಂದೆ ನೋಡೋಣ ಏನಾಗುತ್ತೋ. ಓಕೆ, ಸೊ ಯು ಡಿಫರೆನ್ಶಿಯೇಟ್ ಇಟ್ ಒನ್ಸ್. ಡಿ ವೈ ಬೈ ಡಿ ಎಕ್ಸ್, of course you should write differentiating with respect to x, all those things you will have to write in the exam. Okay, dy by dx equal to a into derivative of cos x is minus sin x plus b into derivative of sin x is cos x. So ನನಗೆ ಇವಾಗ ಬಂದಿದ್ದು dy by dx. What is d square y by dx square? I will differentiate it once again. Minus a sin x derivative is cos x plus b cos x derivative is minus sin x, right? So if I take out minus, what will I get is a cos x plus b sin x. Okay, so this is equal to minus, what is a cos x plus b sin x? It is equal to y. So therefore this is y. Minus y ಈ ಕಡೆ ತಗೊಂಡ್ಬಂದ್ರೆ I will have d square y by dx square plus y is equal to 0. So this is how you can just write verified. ಅಂದ್ರೆ ಏನ್ ವೆರಿಫೈ ಮಾಡಿದ್ವಿ ಅಂತ ಹೇಳಿದ್ರೆ, ನೀನು ಈ ಫಂಕ್ಷನ್ ಅನ್ನ ಡಿಫರೆನ್ಶಿಯೇಟ್ ಮಾಡಿದ್ರೆ ಈ ಡಿಫರೆನ್ಷಿಯಲ್ ಇಕ್ವೇಶನ್ ಬರುತ್ತೆ. ದಟ್ಸ್ ಆಲ್ ವಿ ಹ್ಯಾವ್ ಶೋನ್. ಓಕೆ, ಒನ್ಸ್ ದಿಸ್ ಇಸ್ ಡನ್, we have several problems here in the exercise which are really good problems. I will take up a few which can be challenging for you. I will take the fourth one. The fourth one says verify that the function y is equal to root of 1 plus x square is the solution of the differential equation y dash is equal to xy divided by 1 plus x square. Okay, fine. So look, whenever you get a square root, I suggest you, it is not mandatory, you square on both sides and then differentiate. It would be easier for you. Why? Because the derivative of square root is 1 by 2 square root. So that will be a bit not complicated, I mean can be irritating. Okay, so what I'll do is I will square on both sides. So y equal to square root of 1 plus x square will yield me y square is equal to 1 plus x square. Okay, now I will have to differentiate it once. Why? Because it is given y dash, right? So I will differentiate it with respect to x. I will get 2y y dash is equal to 1 plus x square's derivative is 2x. 1 plus x square's derivative is 2x. One derivative 0, the derivative of x square is 2x. 2 and 2 will get cancelled out. What will I get is y dash is equal to x divided by y. This is what I got. Okay, now we will try to adjust. Okay, this is not wrong. Okay, now we will try to adjust. We have got y dash is equal to x by y, but I need to get xy in the numerator. So I'll just multiply it with y and divide it by y. Okay, so that I'll get y dash equal to xy divided by y square. And here we have y square, you can see. So therefore y square can be replaced by 1 plus x square. So that's all, hence verified. Just write down verified. Fine. Along with this, there are a few more which can be quite challenging for you. If I take up this one, question number 6, y equal to x sin x, y equal to x sin x, and the solution is a bit lengthy. I can say xy dash is equal to y plus x root of x square minus y square. I think this condition will be least bothered. I mean, those are automatically implied, don't have to be worried. Okay, So you differentiate it once because you can see that there is only y dash here. If you have y double dash, you differentiate it twice. Okay, so you have y dash is equal to, now it is x into sin x, so we have to use the product rule. If I differentiate x, I will get 1. I will keep sin x as it is, plus x as it is. If I differentiate sin x, I will get cos x. And now that's all. There is nothing more than this that I can do. But what I'll do now is, look, to match with the LHS, I need xy dash, right? So I will just make it this way. Xy dash is equal to, I will multiply x to all the terms. I'll get x sin x plus x square cos x. Well, that is also fine. But now, what is x sin x? X sin x is y. So therefore, I can just take this up, xy dash equal to y plus x square cos x. Fine, this is also fine. Now looking at what has to be proven. Okay, this term we have already got, this is there and y is also there, but this x square cos x is the only problem that we have right now. Okay, so what I'll do is I will do a bit of reverse engineering. I will come here. Okay, now see, I have cos here, and in the function that they had given I have sine. Okay, how will you get sine from cos? It is only one equation, that is sine square x plus cos square x equal to 1 in trigonometry. So I will come to this. I have y by x equal to sine x is what they have given, right? Andre x equal to, now if I square on both sides, I'll get y square by x square equal to sine square x. Okay, I know that cos square x equal to 1 minus sine square x. Therefore, what can I write here is cos x equal to under root 1 minus sine square x is y square by x square. So if you take the LCM, it would be x square by x square minus y square by x square. Under the root would be x. Take x to the other side, you will get x cos x is equal to root of x square minus y square. So in this, if you want, you can multiply x on both sides. You will get x square cos x equal to x times root of x square minus y square. So if I come here, I will get xy dash equal to y plus x square cos x is x into root of x square minus y square. So hence verified. It can be a very good 3-mark question. Okay, not very easy, not too lengthy. Okay, an ideal 3-mark question. Okay, can be asked. Fine. Once the remaining are not too complicated, you can just try these. Okay, now coming to the last 2 MCQs in the exercise. Okay, the number of arbitrary constants in the general solution of a differential equation of 4th order. I said in the lecture, that is, the order will give you the number of arbitrary constants in the general solution. So general solution ಅಲ್ಲಿ ಎಷ್ಟು arbitrary constants ಇರುತ್ತೆ, order ಎಷ್ಟಿರುತ್ತೋ ಅಷ್ಟು. So 4th order ಅಲ್ಲಿ 4 arbitrary constants ಇರುತ್ತೆ. The number of arbitrary constants in the particular solution ಅಂದ ತಕ್ಷಣ 0 arbitrary constants, only fixed constants ಇರುತ್ತೆ. So therefore in the particular solution of a differential equation, I mean of 3rd order, you will have 0 arbitrary constants. Okay, particular solution. But the general solution anta enadru ee case alli kottididre, you would have got 3 as the answer, but now it is not 3. Okay, it is 0. Fine. So in the next lecture we will see the methods of solving first order and first degree differential equations. Okay.